Hello learners, welcome back to the channel. Hope you all enjoyed the first video of inferential statistics. We learned different things, right? What is expected value, what is binomial distribution, how we can use it, example of finding the probability of fetching two red balls, the example of finding the probability of getting three heads in 10 times you toss a coin, and we learned that which one to use in which. We'll further study today the remaining of the things. We'll study the central limit theorem, we'll study the other parts and also the application of the same. So let's begin. First, what is probability density function? So probability density function describes the continuous random variable. It describes the area under a curve, and it represents the entire range of possible values. So probability distribution function क्या है? ये एक continuous random variable है जो एक एरिया अंडर द कर्व को बताता है, और वो बताता है कि कितनी प्रोबेबिलिटी है इस पर्टिकुलर चीज को होने के लिए. It defines the probability density at a specific point, not the probability of exact values. So it is always greater than 0. So what is the probability? At one point you will have 0.1, then the probability increases as the area increases, and the maximum area can be 1. So like the total area which can be covered can be 1. So this is the probability density function concept, which is used in, again, for inferential statistics. So it is used for probability calculation. As I said, as the area increases, the probability increases, and that value you can use. It is used for parameter estimation. It is used for random sample generation. So for all these values you can use. So when x is a random variable generated, maybe 2, 3 and 4, what is the probability of 3? So like 3 times head, say. So that is what will come as the output. F of x will come as the probability density function, which is the output of when you insert a random variable x. तो जब आप x वैल्यू देंगे तो जो उसका f of x आएगा वो उसका probability density function होगा. मतलब इन सिंपल टर्म्स वो probability बता देगा कि 3 बार होने की क्या है. तो which can be from 0 to 1. It can be 0.1, 0.4, 0.9 or 1 also, right? And the integral PDF yields the cumulative distribution function, which gives the probability being less or equal to a particular value. So cumulative distribution function is when you add two of the values, so it can be same as the probability distribution function, or it can be more as well. So the common example is the normal distribution bell curve, which keeps on increasing, which is like this particular shape, which keeps on increasing from 0 to 1, and it is the highest at a middle point, right, where it is equally distributed on both the side. So this is the normal distribution curve. So it starts like this and then goes like this, right? It is also known as the Gaussian distribution or a bell curve. It is symmetric at the mean. So if you see, this is the mean. So it is same across the mean. It increases till this point and it decreases this point. And if you create a line here, it is symmetric on the both side. ये दोनों साइड पे symmetric होता है. इसके दो पैरामीटर होते हैं, एक मीन और स्टैंडर्ड डेविएशन, जिससे हम नॉर्मल डिस्ट्रीब्यूशन को मेजर कर सकते हैं. It follows the rule of 68, 95, 99.7 परसेंटेज विद इन 1, 3 एंड 2 स्टैंडर्ड डिविएशन. तो जब हम इसका एक स्टैंडर्ड डिविएशन में पीछे जाएंगे तो वो उसका 99.7% एरिया देख लेगा, विच वुड बी समवेयर अराउंड हेयर. सो ये आप स्मॉल यहाँ से छोटा सा एरिया हटा देंगे और यहाँ से एरिया हटा देंगे, तो वो जो बीच का एरिया बचेगा दैट विल बी 99.7 बेस्ड ऑन अवर प्रोबेबिलिटी डेंसिटी फंक्शन. तो जो हमारा एरिया यहाँ पे रहेगा, हमारा एरिया जो है इस पर्टिकुलर कर्व के लिए, अगर हम पूरा एरिया देखें तो ये यहाँ से लेके यहाँ तक का इस कर्व के अंडर का जितना एरिया है ये हमारा प्रोबेबिलिटी डेंसिटी फंक्शन है. तो जब हम एक स्टैंडर्ड डिवीजन हटाते हैं तो एक स्मॉल सा कॉर्नर यहाँ से हट जाएगा और एक स्मॉल का कॉर्नर यहाँ से हट जाएगा और हमको 99.7 मिल जाएगा. जब हम दो स्टैंडर्ड डिवीजन हटाते हैं तो लगभग इतना हमारा, इट इज दिस पार्ट विल बी रिमूव टिल हेयर. सो इफ यू रिमूव दिस पार्ट फ्रॉम बोथ द साइड, सो 2.5% ऑफ data from both the sides, so the middle portion left is 95%. And if you remove the third standard deviation, which will come somewhere, might be here and here, then you will get 68% of the data. So this is how you can use standard deviation and the probability density function, the area inside this, to find the standard deviation values, right? So this is used for phenomena like height, weight, test scores. So if you want to see that what would be the height of say majority of the people, so if you say majority it is 68, so whatever is the probability distribution minus 3 times the standard deviation, that would be the height. So in those kind of scenarios, this is very useful to derive a normal distribution and calculate this particular area, right? Central limit theorem relates to the sum or average of many random variables. So standard mu is 0 and sigma is 1 for simplifying the calculation. It is widely used in the fields of science, engineering, finance and social science, as we are already discussing, right, that machine learning is used in all these particular fields. Now let us see more example of this and how you can use the normal distribution in this. So suppose if you are, as we are saying, we cannot, inferential statistics, the basic concept, if you remember guys, is that you cannot do a particular examples on a small population. You have to do it on a entire big population. It's often more practical and cost effective to collect the data for a smaller and like representative sample. So what is representative sample? Again, it should be the which have a similar mindset or a similar thing. So like if you are collecting the data from an office, it should be from the same office, right? It should be people from the same team where the timings are same, right? So now suppose in an office there are 30,000 people and you have to find the average compute time. You can use a sample of 100 people and you can use a mean of, you can find that a mean of these people are 36.6. So it is not reasonable to assume that population is 36.6 because sample introduces some error. Okay, so when we find the sample, we cannot say that okay, it will be the same for all. So now there would be a margin of error, right? For some people, they might come in 36 minutes. Some people might come early, who are very enthusiastic towards work. Some people might be late boomers who are coming late. They might be working late as well. So it depends on person to person. So we need to keep a margin of error. हमको एक margin of error रखना पड़ता है. हम एक sample देख सकते हैं 100 employees का, क्योंकि हम 30,000 लोगों का जाके डेटा स्टडी करने के लिए हमको बहुत सारा रिसोर्सेज का, बहुत सारा टाइम का जरूरत रहेगा. इसलिए अगेन हम ये प्रोसेस जो यूज करते हैं इन्फ्रेंशियल स्टैटिस्टिक्स का टू स्टडी दिस सैंपल, तो वो कर सकते हैं. जो मीन निकला है वो 36.6 है, बट हम इसको यूज नहीं कर सकते. हम उसमें थोड़ा बहुत एरर, मार्जिन ऑफ एरर आगे पीछे ऐड करके हम उसको ऐड करेंगे, राइट. सो इट रिफ्लेक्ट्स द पॉपुलेशन. दिस मार्जिन ऑफ एरर इज potentially variability between different samples that could be chosen from the same population. In practice, the mean is 36.6. Now the margin of error is the confidence which you want to put for accuracy of the estimate, right? So if you need to understand the concept of this and when the different samples are taken from the population. So if you are want to do like 99% accurate, you can say 36.6 minus 1 time the standard deviation. So you would be 99% sure that it would fall in that particular range. If you want to be 68% accurate, you can divide by 3, subtract by 3 times the standard deviation. So margin of error is a critical concept that helps us inference about a population. So this data which you are doing for a sample, you can inference the same for the complete population as well, while acknowledging the inherent uncertainty due to sample variability. So वहाँ पे हम variability को भी ध्यान में रखते हुए उसको use कर सकते हैं. Now next we have is central limit theorem. So central limit theorem is a statistics concept. Sampling we already discussed a brief about it in statistics, basic statistics. Again we'll just revise it. So sample mean approaches a normal distribution as sample size regardless of the shape. It applies to both large and moderately samples. Typically the size should be greater than 30. So this is something you need to remember. If the size is lesser than 30, then you cannot apply a central limit theorem ideally, because it can be a good approximation but it can be highly skewed. So it is recommended whenever the sample size is greater than 30. It allows you to make a probabilistic statement about the sample using the Z distribution or the T distribution, which will study further. It is important to note CLT does not apply on sample statistics such as mean, variance. The same way it applies to the sample mean. So it applies to mean and not to median and variance. Now it is a crucial sampling distribution. CLT is very crucial. It is used in hypothesis testing, which we'll discuss in very detail in the next coming videos. The hypothesis testing, which will be a new topic for the next videos. You will get the confidence level interval estimation, that what is the confidence interval. As I was saying, you can be 99% confident that it will lie in this range. You can be 95% confident that it will lie in this range. Say suppose the my time is 36. So if you want to be say like more confident, the area would increase, the timing frequency will increase, and vice versa. So these are also used to make inference about the population, again, which we are discussing again and again, the main use case of inferential statistics, even when we don't know the exact shape of population distribution. In summary, sampling distribution and central limit theorem are essential tool in statistics, which enables us to draw conclusion about the population sample data while inherent variability and uncertainty associated with the data. So it is very important to draw some calculations on your sample data, both whether it is a central limit theorem or the normal distribution, to get some uncertainty associated with the data, to get the confidence interval of the data. So that is the main use case of central limit theorem. Now we'll go next in hypothesis testing, and we'll understand what is hypothesis testing and how it is a part of inferential statistics, and we'll see many more examples in our upcoming videos. Hope you are again enjoying all these theoretical sessions. These are very important to understand the basics, what happens in data science, and then very soon when we start our data science core models, you'll see that these are the ones which are used at the backend, and you need to know these basic statistics to get some and solve some problems. Sometimes you don't have to use like sophisticated machine learning models. You can use these techniques of inferential statistics, central limit theorem, to solve the problems. Like we had that example of like people going to office. Similar example is the percentage of lead content in Maggie. So that is also one example that how it is used. And then next we'll see hypothesis testing, which you have to assume what you are assuming is correct or not, which is again extension of what we already learned regarding the confidence interval. Hypothesis testing, we have to we hypothesize something, and then we see whether our hypothesis was correct or not. So this is all very interesting. Hope you are all enjoying. Let us meet in our next weekend video. Stay tuned, guys, and follow and subscribe for more such interesting content. Thank you, everyone.